We are given a square BURN. Let the side of the square measure a unit. So side of the square measures a unit, and an isosceles triangle BAT. Not just isosceles but also right angle triangle BAT. Now it must happen that two sides of a isosceles triangle are equal. Instead of writing BT equal to B, let's just write NT equal to B. Since the triangle is isosceles, BT must be equal to BA, but BA consists of BU and UA, and BU is already equal to BN, both are A unit, so UA must measure B unit. Now, we want to determine angle ART. So we join AR and then RT. You see that triangle AUR must be congruent to triangle TNU because those two sides are equal, and this also measures A unit, the whole length UR equal to RN. So we can use side angle side congruence. Once again, side angle side congruence. So these two angles must be equal. Let this be theta, and then this will also be equal to theta. Now further we are given that the area of triangle ABT or area of triangle BAT equal to area of square BURN. We know that area of right angle triangle equal to half base into altitude or half base into height. What about square? It's side square, so A square. Next, we know the base of the right angle triangle BAT to be equal to A plus B, so half A plus B into altitude. Altitude is also A plus B. Equal to A square. Let us simplify this x1. Take 2 the right hand side, so we will get 2A square. And the left hand side we got A plus B whole thing square. We know the formula for A plus B whole thing square. That's equal to A square plus 2AB plus B square. Further we can take 2A square to the left hand side, and A square minus 2A square is minus A square plus 2AB plus B square equal to 0. Now you see that there are infinitely many choices of A and B that this equation satisfies. But we don't need to solve for A and B. We need to determine tan theta. Tan theta is perpendicular by base, so B by A. So if we can determine B by A, then we are done. So let us divide equation 1 by A square. So dividing equation 1 by A square, we obtain minus A square by A square, 2AB by A square plus B square by A square. So A square will get cancelled, so minus 1, again A will get cancelled, 2B by A plus, we are dividing by A square. So B by A whole thing square equal to 0. Let's write it with the greater power first. So B by A whole thing square plus 2 times B by A minus 1 equal to 0. You see that this is a quadratic equation. There are many methods of solving it, but easier one will be just to write this as 1 square plus 1 square minus 1 square. Advantage of doing so is that this expression is simply a perfect square. So we can write this as B by A plus 1 whole thing square, and 1 square is 1 and minus 1 is 2, sorry minus 2. We take it to the right hand side to get 2. Now it's easy to solve. So this is equal to, this implies b by a plus 1 equal to plus minus root 2. We just take square root both side. Or b by a equal to minus 1 plus minus root 2. But it doesn't happen that b and a are negative. They are the measure of the length of side, measure of side or length of side. They are positive. So if b and a are positive, b by a must be positive. So we neglect. So it follows that b by a equal to root 2 minus 1. Now, but we want to solve for tan theta. Observe that tan theta equal to b by a by trigonometry. Tan theta is perpendicular by base. So b by a, that's simply equal to tan theta. But tan 45 degree by 2 equal to root 2 minus 1. If you are aware of it, well and good. Therefore, theta equal to 45 degree by 2. Now what can you say about angle ART? Angle ART, therefore theta equal to 45 degree by 2. But angle ART equal to, let's look at the figure, theta plus 90 degree. So 45 degree by 2 plus 45 degree by 2 plus 90 degree equal to 135 degree.